All right, so we got our first request. It's on 6.3, vertical stretching and compressions. So the question was, the graph of the function g of x contains the point 5, 1 point and 1/3. So this is my input and my output. What point must be on the graph of y equals 3 times my function g of x plus 1, right? So I'm doing a couple of shifts here. So we got to remember that our input is 5 and our output is 1/3, right? So this is an x value and this is a y value, right? So basically if I were to plug in 5, I get out 1/3, right? As far as our shifts go, we know that anything that happens on the outside affects our outputs. Anything that happens on the inside affects our inputs, right? Because here I'm messing with the x values. Here I'm messing with g of x, right? I'm multiplying my function values, my outputs, by 3, right? So since I was at 5 before, I am now at a different location, right? So this shifts my whole thing, right? So g of x plus 1 is a shift of g of x to the left 1 unit, right? And 3 times g of x multiplies the outputs by 3. Okay, so everything grows 3 times larger in size, right? So what we want to do is we want to think about, I have all this information, right? So what do these shifts do to my point, right? So this is a point that was on g of x, and so it's going to move with g of x as I move the function, right? And I'll show you guys that in Desmos in a second, right? So since I was at 5 and I'm now moving 1 unit to the left, I now have an x value of 4, right? Since my output was 1/3, it is now being multiplied times 3, and I'm going to get an output value of 1, right? Because 3 times 1/3 is 1. So my new point, okay, is going to be at 4, 1. So this point moves along with the graph to this new point, because my graph, if it was here, is going to shift to be larger in this way, right? So a point that was, let's say, here will now move to somewhere else, right? It shifts with the graph, right? So let's go ahead and look at Desmos and see how that works. Okay, I'm on Desmos here. As you can see, I have an arbitrary function. Arbitrary meaning I just made it up, okay? So I made it up in such a way that when I plug in 5, the output I get out when I plug in 5 is 1/3, right? I plug in 5, I get out 1/3. If you're not sure that this is equal to 1/3, you can plug into your calculator. 1 divided by 3 is 3, right? Forever and ever and ever, right? So what's going to happen here is I took my f function, right? So remember, it doesn't really matter what this is. I could have made up a million different other functions that would have the same point in it and maybe look different. Maybe I could have done one that was a wave, or one that was exponential, or radical, or it doesn't really matter what the function looks like, right? I have a function, I plug in 5, I get out 1/3, right? I plug in 5, it says the output here, right? What is my output when I plug in 5? The output is 1/3, right? These things go together, right? I can turn this on and off, right? This point is no longer on here, okay? So I'm going to keep this on. I took my function f of x that I made up here, and I did my shifts. I move it to the left 1, and I multiply it times 3, okay? Boom, that's my new function, right? This one in blue is the new function. So this point that was here, it is going to move with how I move the graph, right? It should move to the left 1 unit, and it should multiply by 3. So it should be up here, right? So over 1 unit, and then it triples in value because I'm multiplying it by 3, right? So my old point was 5. I moved over 1, so my new input would be 4, right? So here I have 4, and I'm looking at what happens when I plug in 4 to the new function. So if I turn this on, and I label the point, you can see it's the point 4, 1, the exact same point that we got when we did it algebraically, right? So this point, it's not going to move directly up, right? It's not moving, because that's not what I did to change this parabola. To go from this parabola to the blue parabola, I didn't just shift it up, right? So this is not the point that this moves to. It's this point. It moves over, and it multiplies in value, just like how it did when I moved this parabola to get to this parabola, okay? I hope this helps. So every time we're shifting stuff, we're moving these things around, and when we move these things around, this point moves around with us. Okay, to help us demonstrate this a little bit better, what I'm going to do is I created some sliders here, right? So our B value was 1, our A value out here before was 3, okay? And so what I'm going to do is I'm going to move the sliders, so I'm going to change the value of A, the multiplier value. What that's going to do is going to shift my parabola in such a way that it moves around, right? So here what I have is I have 4, and then what happens when I plug in 4 here, right? So what's going to happen is as I move this slider around, you'll see how this point that was here will move with this point, right? So we know that it moves over because I'm plugging in 4. In fact, we can even, right, so the value I plug in was always 4 because that's how our shift was, right? So so let's play with this. If I move this around, right, you'll see how I'm always at 4, but what this is doing, it's shifting how this moves, so it stays with it, okay? What I need to do here is let's have this as 5 minus b, and in here we'll plug in 5 minus b. Okay, so what that's doing is it's basically doing the same thing, right? So remember what I had here was x plus 1, so what I had to do was go 5 minus 1 to get the 4 out, right? So what this will do now is it'll always change with how I'm changing this, right? So it doesn't matter, it's still always gonna, you can see it's always gonna stay at 4 here because I'm stuck at 1, okay? So if I move this to what we had before, A is 3, right? So now let's say I move the B, okay? So my original point was 5, and then when I get out of 5 in the f function, I can do the same thing, right? So remember how we did it before. I was at 5, and then I moved to the left 1, so I had to subtract whatever that value was. That's what I got at 4. So now when I play this, we'll see how it changes the output value, but as you can see, or sorry, the input, but the output stays at 1 because it's not moving up and down. It's not magnifying in value, these values. It's just being shifted left to right. So as it shifts left to right, we can see what the new point would have been if I were to shift it by, let's say, instead of 3 times my function and then x plus 1, if I went 3 times my function and then x minus 6, right? X minus 6 means we do a right shift, right? And so my new point would then be at 11 because I moved it 6 units, right? 6 units to the right. So what would be the new input? Instead of being at 5, the new input is at 11. I'm still multiplying it by 3. So what happens when I multiply 1/3 times 3? I get out 1, right? So that's what's happening here. I've changed this in a way so that we can see what's happening to our original point depending on the types of shifts that we had, right? A vertical stretching and a horizontal shift. No matter what horizontal shift, no matter what vertical stretch, right? So we can play these both at the same time. And basically this green dot, what it is, it's whatever these shifts that are going on, it's what this point is. It's always this point. So as you can see, it's growing and it's changing, but it's, if this is the center and this is the edge, this is the center and this is the edge, it's always a same relative distance away, right? So that's kind of what's going on here. I hope this helps. Maybe a little more confusing. We got a little more advanced at the end with these sliders and things. But that's what's happening. As we move these functions, as we translate them, this point is moving with the function, right? So it's still in this place, but I'm stretching it out. So it has to get a little bit further from the center because everything is stretching, right? And that's what's happening as it stretches. As it moves left to right, right? So if I were to not stretch this out and keep it at 1, okay. So it's not being stretched out, but you'll see how now it's just moving left and right with the point. It's the same point, it just stays stuck on my parabola and it's just moving with the parabola as it moves. So as we change this vertical stretching, of course it's going to grow up and down in value because it's the same point. It's just moving as with the graph as we move the graph.